does society have to say? Michael Leunig says the role of the cartoonist, as well as making us laugh at our shared predicament, is to discover and express what is repressed and to say out loud what people everywhere are whispering. So what are people everywhere whispering? We put these cartoons on our math tests, but excuse me, I don't find them funny. Tell us in layman's terms what your breakthrough means, and he can't do that. Society is telling us that mathematics is unintelligible. I had my doctor do a DNA test, blood analysis, and as I suspected, it's missing the math gene. It's saying that we're too dumb to do mathematics. Algebra class will be important to you later in life because there's going to be a test 6 weeks from now. That the reason why we're studying it is simply to do better on the next test, not because we're ever going to use it. And then lastly, how often do you use algebra in your daily life, Dad? Not very often. Then why do I have to learn it? So you can help your son with his homework. We've been doing it for 119 years. Let's not think about it. Let's just keep doing the same thing. We often lament the fact that we go to a cocktail party and people say, I can barely balance my checkbook. But they'll never say, well, I hated English. I hated English. But it's because it's as if we're English teachers only teaching Shakespeare and grammar. Hey, Shakespeare is beautiful. Grammar is a technical skill that everybody needs to know. But in high school, there is a contemporary literature that's part of the curriculum. And what I'm interested in, what is the equivalent, mathematically, of that contemporary literature? Now, I think we can all think of topics that perhaps are part of that equivalent of contemporary literature for mathematics. But there's no room on the curriculum table. If you think of this as the curriculum table, we're constantly trying to shove one more thing up there, but it just falls right back off. So what I'd like us all to do right now is think about a topic that you teach. Everybody, please think about a topic that you teach, that you wish you could drop. It might be good mathematics, but you say, you know, I'd be willing to drop that to make room for a more relevant topic. So everybody please think of that topic. And after you've thought of that topic, then share it with the person next to you. It sounds like we could go on for quite some time, but I'd like to hear what some of these topics are. Yes.
Factoring trinomials.
Yes. Louder. Distance formula. Somebody else. Yes.
Direct variation.
Yes. Somebody else. Yes. Completing the square. Next. Trig identities. Yes. Conic sections. Now the challenge here is the following. For every topic that's been shouted out, there probably is somebody else in the room that says, hey, that's my favorite topic. Right? That is the issue. Because none of this is bad mathematics. That's not the point. It's not bad mathematics. There's just not enough room on the table. So what I'd like you to do for a moment is imagine that we're going to wipe the table clean and there's nothing on the table. And now let's have the discussion about what's the first most important thing to put on the table, and then the second most important thing, and the third thing on the table, and then maybe conic sections makes it on, and maybe it doesn't. I think we all feel that if we had a near infinite amount of time, that eventually we study conic sections or the distance formula, all the things that you've mentioned. But I'm not sure that the topics that have been mentioned would be things that would be easily argued by a group of us to put on the table first. So now what I'd like to do is move towards examples of what I would think would be a relevant curriculum, what I suggest is a relative curriculum, of things that we might put on the table first. And what I'd like to do is go back to the NCCN standards of 1989 and say perhaps these are the topics that we need to put front and center. If you look at the summary from the Common Core standards, notice at the bottom, statistics and probability. There's always at the bottom, and it's usually the last chapter in the book. Only 10% of the SAT 2, Math Level 1, and Math Level 2 are probability and statistics. So let me suggest some of the topics and examples of things that might go on this curriculum table, front and center. First of all, statistics. I think everybody agrees that people should have more statistics, but no one is willing to take ownership for that statistics. College professors want people to have more statistics. We want people to have more statistics, but nobody takes ownership, and I would suggest we need to take ownership for that. In statistics, I think the number one topic that is missing is learning about standard deviation. So this is about diabetes. How many of you know someone personally that has diabetes, taught someone this past year that has diabetes, or have diabetes yourself? Raise your hand, right? This is something that affects all of us. So we have here, there seems to be a lot of buzz about the fact that it's not just A1Cs, that's blood glucose anymore. Rather, it's about the standard deviation to evaluate your success of diabetes management. If you think about it, it's really just common sense. A simple average of your blood glucose over the past 3 months doesn't tell you how far you strayed from the ideal range. You may get an excellent average, but it's nothing but just a middle point. So Dr. Hirsch, a diabetic himself, suggested, just from empirical data, that you should take the standard deviation of your blood glucose times 2, and that should be less than your mean glucose. For example, if a patient's mean glucose is 140 milligrams per deciliter, the target standard deviation should be less than 70. I think this kind of idea could help people with diabetes manage their blood sugar, and it could really help them, but it's not going to help them unless they know what the standard deviation is. And giving them the formula with sigma notation is not going to help them manage their blood glucose. They need to have a visceral understanding of what standard deviation is about. Here's another example. In 2008, the stock market did really poorly. This is 1930 to 2000, and this is market return. And in 2008, yes, the market was awful. But the question that many people ask is, how unusual was the stock market in 2008? In order to look at that, what we need to do is keep the same timeline on the x-axis, but to look at the standard deviation of monthly returns on the y-axis. And if you do that, then you get some sense of the spread, how unusual was it in 2008. And what we can see is, yeah, it fluctuated a little bit more, but was it really unusual? No. Right? Was it really unusual? So I know you can't read all of this. The entire presentation is online. You can take a look at it. I just want to tell you about this project that I do after my students really understand standard deviation. And that is, I give them data that comes from the New England Journal of Medicine, where researchers went around to 5 continents, 43 cities. All these cities had both a KFC and a McDonald's. They purchased fries. They analyzed them in the lab, and the variable that they were interested in was percent of fat that is trans fat. So they had 2 comparative univariate data sets. What I have my students do is analyze these two data sets, and then they see that one has a higher mean, one has a higher median, one has a higher standard deviation, one has a lower standard deviation. Some are skewed, some are not skewed. And what I ask them to do then is to write a paper, as if they wanted to submit it to a journal, saying that McDonald's is the healthier fry. But of course, if you're going to submit it to a journal, you can't say McDonald's is the healthier fry. You have to say things like, the data clearly shows that McDonald's is the healthier fry. And when they're done, then they have to write one that says KFC is the healthier fry. And so here's examples of student work in which, look, this is a box and whisker plot. You can see they're leading you right down the path that says KFC is the healthier fry. It has lower % trans fat. And they say here, and they said in their paper, that here's the maximum of KFC, and 25%, even 25% of McDonald's is above the maximum of KFC. For heaven's sake, you'd never want to buy McDonald's. KFC is clearly the healthier fry. Then what they did, now this is KFC and this is McDonald's. Now they focused on spread, and they said this is the mean plus 1 standard deviation minus, saying down here, and they're saying, look at this huge spread of KFC, and look at this tiny spread of McDonald's. McDonald's is the consistent fry. Don't risk your health by sometimes, right? I call this the spinning the data project, and my students come back and tell me the next day, the next week, and even at reunions, wow, that one project changed forever the way that I consume information from the media. Time out, you might be saying, for whom is this curriculum intended, right? Perhaps you're starting to drink the Kool-Aid, but I got to go back to school, and I'm teaching Algebra 2 next year, and I can't just choose a different textbook. What am I going to do? So I would suggest that at bare minimum, when students leave Algebra 2, and we're scratching our heads and saying, you know, this kid's never going to take calculus, right? And you know, I don't think this kid should really be taking pre-calculus. What we often do is just whatever and pass them on. At least at that moment, we have to say, they're usually done taking standardized tests. Why can't we give them a curriculum that's designed for the world that they live in? And that would include statistics. I believe that we could start pulling this backwards and trying to capture more of this 92%. Remember, trying to push this 8.2% is not a very effective mathematical model. Trying to capture part of the 92% seems to make a lot more sense to me. I think that the standard deviation is the gateway to the normal distribution, and the normal distribution is the gateway to the rest of statistics. So I'd like to talk for a moment. I think that every high school student should understand about the normal distribution. Very often when we collect univariate data, the distribution is normally distributed. Not always. Plenty of examples where it's not, but very often it is. And if you only when you understand the normal distribution can you understand so much of more complicated statistics. So I have my students at the very beginning of the chapter watch a video of a 100-meter dash. And it's very clear in this video exactly when the start is and exactly when the finish is. And they all have a stopwatch that has accuracy to the nearest thousandths of a second. And we watch this video 10 times, and they collect for themselves a little data set that says how long was it from start to finish. And what happens is that this is student A, dot plot, student B, dot plot, and so forth. And there's a hint that each one is starting to form a bell-shaped, maybe not normally distributed, but a bell-shaped distribution. And if we put them all together in one group, then it seems, wow, it seems bell-shaped. Now you can't conclude it's normally distributed, so I have them calculate what % lies within 1 standard deviation of the mean, 2, and 3, and see if it conforms to the empirical rule. And if it does, then they can conclude that it's normally distributed. And it's like magic. Of course, it always conforms to the empirical rule.